Hello, welcome to another video for Year 9 Maths D. We're going to continue the topic variation, but we're focusing on inverse variation. Now, we have to remember that it is actually quite similar to what we have learned in direct variation, but the formula is kind of different. You can see here that it is in when you're talking about inversely proportional, it means that y is proportional to 1 over x, and you have to remember this. Okay, y equal k over x. All right, so k is the constant of proportionality as the numerator, but your denominator will be x. Okay, so let's start with example number 1. Right, find the equation connecting x and y. So you can see here there are 3 pairs of values of x and y. So let's start with the relationship, which is y is proportional to 1 over x, which is actually y equal k over x. Now let's use what we have over here, which is x equal 4, y equal 10. So let's use it. So x equal 4, y equal 10. So you can replace or substitute the values here. So y equal 10 equal k over 4. So 4 will be multiplied into 10. So you will have k equal 40, right? So therefore, your equation connecting x and y is y equal 40 out of x, right? So that's your equation. And what do you notice about the value of k for every values of x and y? So let's see here that from the original y equal k over x, we can change the subject into k. So this one is actually k equal x times y. So let's have a look here with the another pair of values of x and y. So let's use 8 and 5. Now I can see here k equals, what's the x over here? 8, and then the y is 5. So 8 times 5 equal 40, right? So that's the first value, okay, which is actually quite similar to what we have over here, right? So let's check on the next one, which is 20 and x equal 20 and y equal 2. So k equals x is 20 times y equal 2, so 40. So we can conclude that for every values of x and y, k is the same. K are equal, right? So that's the first one, right? Okay, so for the example 1, you can check here, you can look at the workings. Okay, let's proceed to example number 2. Example number 2 here, let's have a look. Okay, y varies inversely as the square root of x, and when x equals 4, y equals 12. So the question is that it asks you to find the value of y when x equal 9. So let's begin with what we have over here, which is y varies inversely as the square root of x. So here is your initial equation, but you can change it into y equal k over square root of x. Right, now let's use the first pair of values that are given to us. So here you can change y and x. It will become y is 12 equal k over square root of your x is 4. So 12 equal k over 2. And you know that here they will be multiplied to each other. So when you have that, you can find k, 12 times 2. So you will have 24. Therefore, your equation, which is the first thing that you have to find, y equal k is 24 over square root of x. So this is your equation of inverse variation. But then you have to answer the question over here, which is find the value of y when x equals 9. So you can start with when x equals 9, you write down your general equation over here, and you know x already, so the one that you're going to change is x. So your x will become 9. So 24 out of square root of 9 is actually 24 over 3. So 24 divided by 3, you will have 8. So that's for the second example too. Okay, you have to remind yourself that you have to substitute the first pair to get k, which is your constant of proportionality. Then you use the equation to find the value that you want. Okay, so that's example 2. Let's proceed to example number 3. Okay, taken from passive paper, November 2002, paper 1, question number 19. Okay, let's begin to read the question. The force of attraction between two magnets is F newtons. So that's your first value. Force equals F. And then this force is actually inversely proportional to the square of the distance d. So from here, I will just write down that F is inversely proportional to the square of the distance. Okay, so that's your first initial equation. But then let's see the question first. D centimeters between magnets. Okay, let's go to part A. When the magnets are at certain distance apart, the force is 10 newtons. And then what's the question over here? What's the force when the distance is double? Now here, it is quite vague at first when you read the question, but if you remember what you have done with proportional topic, you can always deal with this question without knowing the constant of proportionality. So let's have a look here first. Okay, now when you're going to do this, let's use what we have as the values, which is distance squared, and then it is actually over here. Okay, let's tackle the value first, which is when the magnets are at a certain distance apart. So let's have the distance first. Okay, distance, let's say I consider the certain distance at the first one will be x centimeters apart. So the first force that I have is 10 Newton. So here I will use a proportional ratio, d squared and then f. Okay, don't forget that d is squared in your value over here, so that's why I put square. So if the first distance is x, right? If the first distance is x, I will write down x squared, right? So it is equal to 10, right? Now, the question asks you when the distance is double, so your second distance will be 2x, right? But then we have to consider that the distance is squared, so I will just put d2 squared. So the whole expression will be squared, so it is equal to 4x squared. So I will put this 4x below x squared, and then it's equal to what you're looking for, which is the force. So when you compare x and 4x, and this is proportional, so I will use the proportional method, okay, to compare 1x, it becomes 4x because you are multiplying by 4, right? Remember that. Okay, now what we're going to do with the right one, you are using the same method, but then remember this is inversely proportional, so basically you have the opposite of what you have done in the left hand side. So when you multiply by 4 on the left hand side, so here you are doing something with 4 also, but instead of multiplying, you are dividing it. So there you have it. So your force is 10 out of 4. So 10 out of 4, which is 5 out of 2. Okay, so your force is 2.5 Newton. Okay, how do you know that your answer is correct? Is because here, when you're talking about inversely proportional, you see that the distance is increasing, right? So I will just put an arrow over here, increasing. But you can see that your force is reduced. So it is decreasing. So this is proportional by inverse. Okay, right? So that's for A. Let's have a look at part B. Write down a formula connecting F, D, and a constant K. So this is force, this is distance, and constant K. So a straightforward one, you can just write down F equal K out of D squared. Okay, where do I got it? It's because I have it here on the first place here. F is proportional to 1 over D squared. Right, now let's answer part 2. The final part. Okay, I forgot to write down part 1. Okay, part 2. Okay, when the magnets are 3 centimeters apart, the force is 2 newtons. So find the force when they are 5 centimeters apart. Okay, so here let's begin with use D equal 3 because that's the first given value. And then for 3 centimeter distance, the force is 2 Newton. Okay, so I will just straight away put the values in. So I will just put it here. F is 2. F is 2 equal K over distance is 3 squared, right? So let's have a look here. And you have 2 equal K over 9. So when you move over here to the other side, your K is 2 times 9, 18. So therefore, your initial equation, it becomes F equals 18 out of D squared. Right, so you're going to use this equation to find what you're looking for at the question. Find the force when they are 5 centimeter apart. So your new distance will be 5 centimeter. So when D is 5 centimeters apart, F equal 18 over D squared. Your D will be substituted into 5 square. So 18 out of 25 Newton, right? But here it's up to you. You can change the fraction into decimals. So if you use your calculator, you can have 18 out of 25, which is 18 times 4. Okay, 18 times 4, 32, 72 over 100. So when you have 72 over 100, it is actually 0.72 Newton, right? So this is your final answer. All right, so that's it. I hope that it helped you to answer all the questions in your notes. Don't forget that you have to stick your notes in page 42 and 43. And that's it. Thank you very much and see you again.